All right, remote calculus, here is in all calculus, here is a review video for your exam number 2, chapter 2 exam. All right, this is video number 1. This is mostly talking about evaluating limits, which is over half of this exam. Limit as x goes to -3 of this rational function f of x. You can just plug -3 in for x, and you get 65/8. That one is simple. Number 4, the limit of f of x as x goes to 5. You need to factor this top. 3 times x squared minus 25. This is the difference of two perfect squares. Now the x minus 5's cancel. You have the limit as x goes to 5 of 3 times this. Make sure to write the limit as x goes to 5 until you plug 5 in for x to get 30. All right, again, pause this whenever you need to. There's a lot of work shown. The limit as x goes to 3 of this rational function, x cubed minus 27, the difference of two perfect cubes. That is x minus 3. Take the cube root of both, square the first term, the opposite sign, the inner product is 3x. Square the second term, plus 9. The x minus 3's cancel. X squared plus 3x plus 9 divided by 5. Plug 3 in for x. You get 27/5. On 7, now we did that today in our Google Meets. You're going to multiply the top and bottom by the conjugate root x plus 5 plus 3, top and bottom. You got x plus 5 times x plus 5 both in the root. It's going to be leaving you with x plus 5. -3 times 3 is a minus 9. That gives you x minus 4, which cancels now with that x minus 4. You're left with 1 over roots x plus 5 plus 3. Now you can plug 4 in for x. Root 9 plus 3 is going to give you 6, 1/6. All right, number 8. The limit as x approaches 6 of this f of x. Factor the top, x minus 6, x minus 3. This will cancel these two, that is. And that's -1. So you got the limit as x goes to 6 of -1 times x plus 3. Now plug 6 in for x. Limit as x goes to infinity of that. So the square roots of this divided by this. So this is the most important term you're going to consider. Think of that as root 3x squared, and this is the most important term. So that's essentially limit as x goes to infinity of the square root of 3x squared divided by 7x, which is the limit as x goes to infinity of square root of x squared is x, root 3 there. X's cancel, you're left with root 3 over 7. Number 9. I know there's something's going on weird here with the lighting, but see if that changes any. The highest power is both up top and down below. It's the same highest power, so the horizontal asymptote would be the ratio of the leading coefficients. Horizontal asymptote, again, is the limit as x goes to infinity or negative infinity. 5 over negative root 9, -5 over 9. On 11, the highest power is in the denominator, which means the horizontal asymptote is y equals 0, so that means the limit is 0. 15, the top factors would be, even if you didn't know what the top factors would be, you're going to factor out the 4. It's going to be 4 times x minus 3. You know that you have to have an x minus 3 up top because those have to cancel. You're in a 0 over 0 indeterminate form situation, so you know x minus 3 is going to have to be a factor, and the other one is 3x plus 5. Those cancel. You're left with the limit as x goes to 3 of 3x plus 5 over 4. Plug 3 in for x, 7 over 2. All right. On 16, going to multiply the top and bottom by root x plus 5 plus 3. And while you're doing that, factor out the 2 they have in common to get 2 over 4 minus x times that conjugates. Here you're going to have x plus 5 minus 9, which is going to be x minus 4. So these will cancel to give you -1. -1 times 2 is a -2 times that conjugates. So plug 4 in for x. You get -12. 17 is one we did today. X to the fourth minus 16 is x squared minus 4, x squared plus 4. The bottom factors would be 3x plus 4, x plus 2. This is the difference of two perfect squares, x plus 2, x minus 2. The x plus 2s will now cancel, which is great. Now I can let x be -2, plug -2 in for x. You got -4 times 8, divided by -6 plus 4. Negative divided by negative is a positive 16 there. Unless, nope, I don't think we made a boo-boo. I think that's good. And then 18, the limit as x goes to 12 of root 3x minus 6 all over x minus 2. You got another 0 over 0 situation. So you're going to multiply the top and bottom by this conjugate, root 3x plus 6, giving you 3x minus 36. And then you're going to factor out, you know, over x minus 12 times that conjugate. You're going to factor out the 3 they have in common up top. This is great because now you have x minus 12 over x minus 12. Cancel. So you have the limits as x goes to 12 of 3 over root 36 plus 6. You get 1/4. All right, going on to the next page. Number 21. F of x is equal to that piecewise function. It says find the value of x or of c so that f of x or f is continuous on its whole domain. So I want to be able to make this graph without picking up my pencil. That means this must equal this when x equals 6. I got to get the same y value. So that open circle will be covered up by that closed circle. So these two would be equal when x equals 6. So I'm going to plug 6 in for x, 6 in for x. Then I'm going to solve for c. All right. And I'd expect to get a goofy answer. That's happened for us a lot. Then on 22, evaluate each limit if it exists. So what we have here, piecewise function, a is the limit of f of x as x approaches -2 from the left. The left of -2 would be less than -2. We'd be using equation 1. All right. So I'm going to plug -2 in for x in that first equation, which is 2x squared minus 5x. I get 18. The limit of f of x as x approaches -2 from the right to the right of -2 means greater than -2. I'm going to use the second equation. Plug -2 in there. 12 minus 3 times the -2. 12 plus 6 is 18. Notice how the left-hand limit is equal to the right-hand limit. So the limit as x approaches -2 as a whole is, in fact, 18. On D here, we have the limit of f of x as x approaches 3 from the left. Let's also look as x approaches 3 from the right. Again, minus means left side, plus means right side. The left of 3 is less than 3. We're going to plug it in right there. The right of 3 means greater than 3. We're going to plug 3 in right there. So we get both left side of 3, we get 3. Right side of 3, we get 21. The left-hand limit doesn't equal the right-hand limit, so the limit does not exist. All right. Lastly, 40 here. Again, we're tangent line derivative ones, another video. Use the intermediate value theorem to show that there exists a root of the equation in the given interval. So there's f of x. Find f of 1. Plug 1 in for x, you get 7. Plug 2 in for x, you get a -2. So I was above the x-axis. Now I'm below the x-axis. I had to cross the x-axis, which is the definition of a root. I crossed 0, so I have a root between 1 and 2. On C, another time with E, plug 0 in for x, you get e to the 0, which is 1. Sorry, I made a mistake. 1 plus 1 is 2, so that would cost you. 1 plus 1 is 2. E to the 0 is 1. Then I plug 1 in for x. I get e to the first minus 3. Again, using your approved calculator here, it would be second, right? Where's e? It's up here. Second natural log. It's got to be on. All right, second natural log. You got e to the first, hit enter, minus 3. There you go, -0.28. Cross 0 again, so a root exists between 0 and 1. All right, I feel pretty good about those answers. This is Yak Math Videos signing out.